So, hello everyone, and welcome to the OAI webinar series, chapter 10. I hope that everyone can hear me well. So, this webinar is presented by the OAI strategic partner Firecell and is entitled Open Source and Open RAN 5G Networks Research Test Deployment from the Lab to Beyond the Lab. Our speakers for today are Claude Serra, the CEO of Firecell, Nicolas Tondre, the product manager at Firecell, and Anurag Asokan, the RAN software architect and lead developer at Firecell. So in today's webinar, and as you can see with the agenda, the Firecell team will start by welcoming you and with an introduction. Then on the second point, we'll talk about open source in 5G, the way to accelerate telecom innovation. After that, we'll have a demonstration of a simple and customizable OAI 5G distribution. On the fourth point, we will go from the lab to the field, and the Firecell team will show you how to test and commercialize your 5G innovations on a grand scale. And then we'll come to a conclusion and to a Q&A session. So I just want to remind everybody to keep your microphone muted, and you can ask questions in the chat. But just note that the Firecell team organized a Q&A session at the end of the webinar to answer all of your questions. With that said, I think I can stop to share and leave the floor to Claude. Thank you. Oh, I will stop sharing.
Okay. Good morning, good afternoon, good evening, everybody. I will try to take the lead on sharing my screen. 1 second. Can you see my screen?
Yes. Yep.
Okay. Good. Thank you everybody for joining this webinar. It's we are very happy to be here with you. We'd like first to have a big thanks to the OAI Foundation with Camille and Irfan, Raymond, Robert, and all the other active members inside the OAI organization for the support, for the day-to-day help in really improving and working with OAI. And I want to say a few words before why at Firecell we chose OAI and we chose open source as a strategic foundation for our business. First, we realized, and I think we are not the only one, that every country in the world is now opening 5G frequencies for enterprises of all sizes. And really in that scope, we really wanted to make sure that 5G can be available to everyone. So far, wireless technology was really for the happy few, the ones who were working at the big telecom operators or the ones who were working at the big manufacturers or big vendors. And we thought that it was moment to actually democratize 5G and put it in the hands of everyone. So if I may first, why open source? Why does open source exist? I mean, the first is it has been proven many times that over time, open source quality of code is much higher than non-open source quality of code. The beauty with open source is that the code is constantly improved by the community, and over time it reaches a higher standard. And of course, the larger and the older the communities, the better is the quality of the code. Okay, it's a path, and I think OAI is really getting stronger in the improving and making the quality of the code close to deployment grade. We'll talk about that later. Second, it provides security to all the people who are deploying the code because open source code is transparent. It can be analyzed by anyone, by any tool at any time. It means that there is no backdoor possible. And if ever there is a backdoor that is detected in the code, okay, it can be fixed by anyone in the community. We saw that happening again and again on all the open source we see on the market, that when there is a security flow, it's fixed in a matter of days. Okay. And third, open source provide independence, okay, to our customer and to the overall community in general. One can add functionality, fix the bug by themselves, modify, basically adapt and adopt the software for their own purpose. So that's why open source exists, and I think it has proven successful over time. The question is then, why open source in telecom? It even makes even more sense to use open source in telecom standard, because telecom standards are directed or defined by specifications such as 3GPP. And if you look at the big scale, if you take one step back, it's such a waste of energy and a waste of innovation potential by having thousands of developers redeveloping the same thing again and again. The 3GPP specification is fixed, is defined, is evolving, but it's the same for everyone. Okay. Of course, there are difference in terms of how you implement few things and so on. But finally, at the end, is the same type of codes that is run by everyone. So open source and putting all our energy in one common platform, which would be open source, is for us the most economical sense of developing telecom solutions. And then inside the telecom and open source, why we chose OAI? We chose OAI for 5 real important reasons. First of all, OAI is really run by experts, okay? OAI has been founded by Eurocom, which is a very well-known research institute in telecommunication. OAI is led by telecom experts. I mean, the team in OAI, if you have 5G questions, they know by heart the specification, they know where to find it, they are really experts in their field. Second, it's a fully independent and neutral non-profit. It is not linked to any company. It is run as a non-profit, and that gives the independence that we need to have to see the code in the long term. The support, it's widely supported by telecom players. We can mention Qualcomm, Sequans, Firecell, Fujitsu, Orange, NVIDIA, Canonical. All these companies are actually supporting in a way or another the OAI. Would it be with funding as well as tool, materials, whatever, there is a wide range of support behind the OAI. One very important thing that is often not understood, the OAI license scheme, the license is sound and fair. It is well adapted to business practices in the telecom industry. As you know, 3GPP is full of innovation and technology that has been brought by many different players, and they have IPR behind this technology. And the OAI license is fair in a sense that it doesn't deny that. Okay, so I think it's very important to have the acceptance on the overall community by of these OAI is that these licenses have been well designed and well defined by the OAI. And the final, and I mean, it's maybe one of the most important, it's real. Okay, it's not just marketing. It's 3 million lines of code, 200 plus contributors. If you search on Google Scholar, it's 22,000 research papers mentioning 5G and OAI. You would never see anything like that in terms of the activity that OAI has been created and the innovation that has been brought by OAI. That's why we decided to choose OAI, and we had different other options in front of us. So not only we take all these good benefits from OAI, but also we are committed to OpenAirInterface. Okay. We are committed to help users find 5G users, for researchers, teachers, and innovators to actually not spend their time in making things work. By pre-packaging, pre-configuring hardware, software, we make the solution quite easy to set up and easy to start with. Okay, still keeping the open source flavor. It's also, we make OAI easy for industrial companies to deploy and digitize their operation using private 5G. This is a topic that is at the beginning of the market and growing quite actively these days. And all in all, with the objective to have a super easy solution, which easy doesn't mean simplistic, okay? Easy means the right level of complexity for the right people. When we are dealing, do not have any 5G expertise, we try to hide it and to make easy. But when we are dealing with people who have who are developers and are doing actually innovation in 5G, we don't want to hide either the complexity and the possibility. And that's what we hope to demonstrate. We hope to demonstrate in the next few 20 minutes. And our objective is really to develop, package, distribute, and support the world's first OAI distribution of 5G core and 5G radio access network, all together with integrated hardware, with finally the objective to democratize 5G network for all category of users. And what we believe, and I mean, it's not we believe, I mean, it's well known, open source is eating the world, okay? And I suggest that all of us in this community, we confirm OAI as the dominant platform for wireless telecom, for open source wireless telecom. At Firecell, we are committed to pushing vast majority of our 5G development. As soon as it is in the core, it is in the RAN, it is bug fixed or standard feature, we will provide pushback our modification to the code source, and we recommend you to do so. We recommend you to contribute. Every small bugs you find, everything you could propose, please redirect it to OAI, because all together we are much stronger. And you can count on us to help you use OAI with our pre-packaged product and with our support that you will see in the next few slides. And I think now time is for the demonstration.
Thank you, Claude. Hope I'm audible to everybody. So, good afternoon, everyone. Thank you so much for joining us today in this webinar. It's truly a pleasure to have such an engaged and diverse audience. So, your presence here is highly valued, and we are excited to share some valuable insights with you. So now let's dive into the topic that I'm here for, the Firecell CLI and the demo that I'm going to give on ORAN. So for those who are familiar, the Firecell CLI is a powerful text-based interface that we have developed, much like our familiar Linux bash shell. And what sets it apart is its interface.
Are we losing Anurag? Or?
Anurag, we can't hear you anymore.
Okay.
I think
let me know if it's okay.
It's better. Yeah.
Okay. So coming back to my point, like whether you're a student diving into the world of command line interfaces, or a developer configuring and testing, or an administrator managing complex network setups, Firecell CLI caters to all. Its versatility makes it equally suitable for all the users of any background and any expertise level. And its auto-completion features makes complex commands.
Anurag, we lost you again.
I'm sorry, I think the Wi-Fi is giving me some issues here. Okay, let me know if it's okay now.
Yeah, it's back.
Okay. Okay, let me share my screen for a small PPT. So is it visible?
Can you put in full
Yes.
screen mode?
Would you?
Can you put in slideshow mode, Anurag? Whoops. We can't hear you again.
Seems like there's. Okay. Let me know if it's okay.
It's okay.
Yeah, we can hear you.
Yeah. So I would like to continue with stating that this is the whole LAFIT or an architecture. We have the core network and the RAN, along with some of the utilities like network management system and the command line interface, all packaged in one single box of hardware. And we have a ready unit. And we are also using
And we lost you again.
Maybe you can try to disconnect and reconnect.
Yeah, let me try reconnecting. Okay, thank you.
Maybe we can dance a little bit to keep the keep the energy flowing while Anurag is getting back.
Yeah, we have a question in the chat. I'm not sure if either Nicolas or Claude can answer in the meantime. Or maybe Anurag can answer that when he is back. All right. Anurag, I'm not sure if you are speaking, but we still can't hear you.
You are noted as muted.
Is it okay now?
Yes.
Yes.
Okay. Okay, so coming back to my PPT again. Sorry for the continuous interruptions, but it's really unfortunate. Let me know if you can see my screen.
Yeah, go ahead.
Yes.
Go ahead.
Yeah. All right. So yeah. So today's demo, I'll be presenting with this particular hardware. So I have a pre-recorded session for this one. So since we have lapsed some time, so let me jump into the demo directly. Let me know if the screen is visible.
Yes, we can see it.
Okay, so we start with Firecell CLI. So this is the environment I was speaking about. So once we enter the Firecell CLI, you can see a prompt called FC. So this indicates that you're at the right place. You are already in the shell. This CLI will tell you the kind of radio that you're using, which is ORAN in my case, and the version is 30019. And in this CLI, you can use the command help to find out all the commands that are supported by the CLI. So we have a general set of commands as well as ORAN specific control commands. So if I go to the general commands, it's a general set of commands which will control the whole software. And if I give help ORAN, I can go to ORAN specific commands, which is used to control and configure the ORAN RU as well as the ORAN GNP. It also facilitates to get a lot of configurations and control related information from the RU.
Anurag, sorry to interrupt you. Yes. Someone is asking if it's possible to increase the font size so that for readability.
Sorry?
If it's possible to increase the font size.
Well, it's a recorded session, so unfortunately I can't.
Maybe zoom in that case a little bit, just so you can see if you're able to.
It's again not possible. Sorry.
I mean, what we can do is that after the webinar, you can share me this
we can
video
share the video
and
with everybody. Yes.
Yes. So I will put it on a website and everyone can see it afterwards.
Okay. So let me resume.
Sorry, let me give a recommendation. In the left hand side, in the down side, you can actually increase the size of the windows that you're seeing. There is a plus and minus button next to Anurag name, and you can zoom in the video. So for the people that is having difficulty seeing due to the size, you can do that.
Yes, I think you're speaking from the people who can do that. Yeah.
Okay, go.
Oh, yeah. So we can start to deploy the core network with a simple command called deploy 5GC. So let me show you how we can deploy the core network with a simple command. It seems to be having problems again. Okay, so let me try that again. So you can see that we are running the command docker ps -a just to show that we have only the NMS related containers running at the moment. So to deploy a 5G core, we execute the command deploy 5GC. So as soon as we deploy 5GC, we can see all the containers related to the OAI core network popping up as well. So it takes only a few seconds, but you can see each of these containers getting deployed one by one. So it also does the health check additional to what we have in the OAI health check scripts. So once deploy 5GC is executed, it will provide you a status of the containers which are deployed, and it will show you like what is active and what is inactive. So we are using a basic deployment model for this particular deployment here. So we are not deploying all the core network containers, and you can see that we have all these containers shown as active at the moment. So if you scroll up, and you can see all the other containers being active here. So coming to the shell, if I want to check with normal Linux commands, this shell also supports Linux commands by using an additional command called execsh, which is to execute shell commands. So you can see that on the top, you can find all the Docker containers again. So I'm running the T# to capture the NG AP packets, and now I will be focusing on starting the Gnode B. So before that, I would like to tell you something about the initialization of ORAN Gnode B. This particular procedure is involved with several steps, which takes like 5 minutes, because it's like a whole boot up procedure. When I say boot up procedure, it is going to reset the RU, and it is going to reset the DU host, and it is going to start several steps like initializing the DPDK layer and PTP and carrier activation in the M plane, etc. and etc. So I would be only going with checking on the status because it is recorded. So you can see that when I check PTP sync, it is going to give me a status of the current PTP synchronization. So the RU will return a status that it is synchronized, and you can also check what is the status of the carrier in the M plane. So you can just check ORAN carrier status, which is going to return either activated or not activated. So in the end of the session, I will show like how to deactivate the carrier in the M plane as well. And after that, we can start the Gnode B. So once the Gnode B started, you can see that there is a ng setup request and response captured on the OAI core interface. So that means that the Gnode B is able to communicate with the core, and we can start the UE to have an active data traffic now. So once this step is achieved, we can put the UE back to disable the flight mode and see what's happening, what happens with the data traffic, and how we can monitor the different actions, different things that we need to monitor from the UE. So you can see on the bottom left corner, it connects immediately, and as you can see all the NGAP and NAS messages on the bottom right corner. And now I'm going to show like how we can use a different commands inside to see and monitor the performance. So I'm using this command report cell status, which is a subcommand. And with this command, you'll be able to monitor the DL throughput and DL PRB usage, uplink throughput and uplink PRB usage, and other related parameters. So in this configuration, we are achieving like a 300 Mbps close to. I will run it again to show the uplink throughput as well. So you can see that on the uplink throughput side, it is peaking. So let us run it once again. Yeah, you can see the uplink throughput is peaking to 45 Mbps or in this 50 Mbps and so on. So yeah, currently we are running in band 77 and a bandwidth of 100 megahertz at 3.9 gigahertz. So that's why we are achieving this throughput, and it is also single layer. So we are peaking up to 330 Mbps max. So there is another command which I would like to show you, which is the report UE status, which is to get some information about like a number of bytes transferred in each LCID in the uplink and downlink. So at this moment, I would like to also quote that we have a Firecell NMS dashboard, which also shows this information like bitrate and the resources also, and also some cell related information, which we can see here. So you can see that I'm running the test again. I'm running the throughput test again, just to see that what's the throughput. You can see the bit rates is spiking to 353 Mbps because like there is a slight overhead also. And the same for uplink test. As you can see, this uplink test is starting now. So you can see the uplink also performing according to what you see on the UE side. So coming back to the information about the RAN side, you can see that this particular information is also displayed on the bottom, the uplink and downlink throughput. Along with that, you get more information about each cells, like in what frequency, what bandwidth, and what band they're using. All this information on the bottom. So we have another tab, which is for adding and deleting UEs, to add new subscribers and remove them. You can see all the status. And here's how you can add a new SIM card. So addition and deletion is quite easy. You can you can see that on the top corner there is a delete button to remove a UE, and that is pretty much that I want to go through for the dashboard part. I would like to come back to the CLI part again. So once I would like to show the same set of configuration, what we see on the dashboard here as well. You can get to know like all this information here, and also the radio configuration, like what is the clock source and how the radio is connected, all this information here. So currently we are using a C1 setup, so because of which we are connecting the Grandmaster to the GPS to the Grandmaster, and which is connected to an E810 card of Intel, and we are using PTP4L and PHC2sys to send that signal to the PT packets to the RU. So if coming to the ORAN related commands, we have a wide range of commands which we can use here. So we can use to upgrade the RU. You can check what kind of what's the firmware version that we have today, and if there is any updates, it will recommend you to do an update. So today the firmware is same, so it will say no update required. But otherwise, you can just run the command ORAN update RU firmware, which uses the netconf commands to fetch the RU firmware, and it will upgrade the RU firmware accordingly. So this uses the NetOpenAir2 CLI internally, and it communicates to the RU to do all the relevant operations. So this is another command, which is LPRU configuration, which is to read all the registers inside the RU to know all the information that you need. So it will fetch all the information and save in a file, which you can refer to and understand what's happening inside the RU. I'm not showing the contents of this one here. So another set of utilities is related to show command. Not show command. It's a report command. So in a report command, you can report different things like a PHR, RSRP, etc. So it will report the PHR, last 10 known PHR from the UE. This is configurable, this number. We can decide to choose have more numbers. So today it's configured as 10. So it shows the RSRP and PHR in this particular section. So all these RNTIs is for the same UE, which might be connecting again and again. So this is one thing to note here. So as I mentioned, like you can use exec sh as a command, which will do the same operations as how we do it in Bash. So I want to show you that all of this software is packaged as a Debian, and you'll be able to upgrade the software, the whole software with the apt install or apt upgrade for that particular software. So it is quite easy like that. So these are the basic operations, and I would like to also show you how to deactivate a carrier, which we mentioned here. Like it's as simple as ORAN deactivate carrier, and to stop a G node B, ORAN stop G node B. And if you want to restart the G node B, it's just ORAN start G node B again, which will do it faster. So now that I've deactivated the carrier, you can see that if you check the ORAN carrier status again, it will say that it is now deactivated. It's because of its thread, it's not very visible here. I understand that. But yeah, the activation and deactivation of carrier over the M plane is quite easy with these commands to enable the user RPs. It's quite simple. Now I can come back to other set of utility commands. So before that, I would like to undeploy the 5GC. So it's once it is undeployed, it will remove all the network containers as well. So that's simple as that. So we can check all the containers now. So when you check Docker ps-a, everything else is removed now. And additional to this, I would like to also talk about the other utilities like changing the log levels and stuff like that. So so for that, we will be using commands like cn log level and gnodb log level. So these commands will help us to change the log level, but care to be taken that we have to restart the gnodb or core every time that we change it. So on the top, on the bottom corner, left corner, I'll be showing the configuration file and how it dynamically changes the log level inside the gnodb. So this is why we need to restart the gnodb every time. So let us open the configuration file. So it's the gnodb configuration file, and there's a log config on the bottom. So you can change to debug, error, or info. So once you change it to debug, it will be applied there immediately. And if you want to put it to error, you can just give error and it will be updated. And you have also info log level, so you can change gnb log level to info, and it will be applied. So similarly, we have the same set of commands for core network also. It will change to whichever log level that you want to set. So all these commands are detailed inside the help section, and you can always do a help space the command, and you get further details about how that command operates and what has to be done. So that's all from me. Yeah, I would like to hand over the presentation to Nicola now. Thank you.
Thank you, Anurag. Thank you very much for the demo. I think you should have plugged your microphone wirelessly to 5G. It would have surely worked better in the first place, right?
Yes, you're right.
Okay, let me share my screen. Can you see the slides now in full screen?
Yes.
Okay. Well, thanks again, Anurag. Great work. Now let me introduce myself. I'm Nicolas Tendre, and I'm a product director at Firecell. And I'm here to show you how our customers are using our great products to test and commercialize their own 5G innovations on a grand scale. I will focus on two lines of products that we developed at Firecell, LabKit and Orion. So LabKit is an open source 5G network for indoor developments, proof of concepts, and demos. It's dedicated for R&D labs, universities, and innovation centers of any kind. Whereas Orion is the same philosophy, but for outdoor and large indoor premises. It's also for making pilots, and it's dedicated mostly for university campuses, fab labs, warehouses, and factories. I won't be talking today about our third line of products, which are dedicated for the industry. It's called Pegasus. That's for our commercial deployments. So let's first look at LabKit. LabKit comes in two flavors, LabKit 40 and LabKit 100. The number corresponds to the actual bandwidth that you can use with the chosen flavor. Both lab kits are open source, of course. They allow you to set up a 5G network for your own developments, for proof of concepts. They're composed of OAI's 5G core, the Gnode B, and Firecell's network management system that Anurag has demonstrated to you. It runs on a COTS hardware, and you choose the SDR according to the desired bandwidth, 40 or 100 megahertz. So the 40 megahertz SDR has a power of 10 milliwatts or 10 dBms. The 100 megahertz SDR, software-defined radio, runs up to 63 milliwatts of power, that's 18 dBm. And they can both cover a large room. Perfect for testing in a lab. Lab kits, they're both come with SIM card that's pre-provisioned to work with the network, and of course, a smartphone. So when you unpack it, it works out of the box. And LabKit is our best-seller product. We have over 50 companies worldwide that are using LabKit. There's another flavor of LabKit that we just came out with and that Anurag has demonstrated. It's LabKit ORAN, Open RAN. So it's very similar to the other LabKits, except it comes with a radio unit that is an Open RAN radio unit. It's available currently in the following bands: N48 for the US, N77 for part of Europe, including France, and N78 for the rest of Europe. It also comes with a smartphone and a SIM card so that when you open it, you plug it and it works. So this one is not only open source, but Open RAN. And as you know, Open RAN Open RAN has standardized the different interfaces inside the radio access network. So with this LabKit ORAN, you can use Wireshark to understand all the messaging protocols within the LabKit and also set up your own developments, pilots, and do your own code. Firecell will be there to support you with Anurag and his colleagues. Let's have a look at Orion now. Orion comes also in two flavors, Orion 50 or Orion 100. 50 is the bandwidth of the radios that come with Orion 50. 100 is the larger bandwidth, the maximum bandwidth that you can use in 5G with this flavor of Orion. Orion 50 comes with the same software as LabKit, but with more powerful radio units. Orion 50 comes with a 20-watt radio unit that can cover up to a few kilometers, and Orion 100, only 2 watt, that's up to 1 kilometer. And the bands they're available for are the same as for LabKit Open RAN, 48 for the US, 77, 78 for Europe. Now, Orion is made for larger deployments, for larger pilots. I mentioned warehouses, factories. So it comes with 10 SIM cards and a choice of user equipment, such as 5G cameras, tablets, barcode readers, industrial routers. I won't delve into the network management system that you already saw with Anurag. Two main features: monitor the network and manage the devices. Now I would like to show you some examples of actual uses of Firecell's products. This one is from Lawrence Berkeley National Lab in the US. They're using LabKit for demonstration edge to core connectivity. And this picture comes from a demo that they've done in an event in Denver, teaming up with Verizon Wireless. This slide shows a deployment that we've made at the camp in Aix-en-Provence with our Orion radio. Let me show you the video that will showcase the installation, the configuration, and the testing of a typical network that we've done on the campus. So that was Orion at the camp. We installed there a 2 watt radio unit at 100 megahertz, Orion 100. So you're of course welcome to come and see the deployment at the camp. It's open to everyone to see and bring your own devices. Whoops. Yeah, one time is enough. The next example is Firecell Private 5G running at Team Henri Fabre. This is in Marignane, close to Marseille. And it's a fab lab where you see lots of different tools. And 5G was introduced there so that people can use their own tools and their own processes with this new technology that we're bringing them for wireless communication. And finally, this demo is probably the most exciting of all. It's the last one I'm going to show you today. It's Firecell's private 5G running at Stanley Robotics. This company has set up robots to automatically park cars in the Lyon Saint-Exupéry airport. The demo is very short. Have a look. That was Stanley Robotics using 5G from Firecell. So they chose 5G in this context because 5G allowed them to cover the whole parking lot with only one radio and benefit from a low bandwidth that's very important if you want to send emergency messages to the robots in case of danger. Well, that's it for me. That's amazing. No, thanks for listening. And back to you, Claude, for a wrap up.
Okay, thank you very much for your time. We have, I think, only 5 minutes left. I think we are answering on the question on the fly. And anyway, we will collect all those questions and answer one by one and send actually all the answers to you, back to you. I would like to thank you very much for your time in this webinar and demonstration. Thank you, Anurag, for this. Thank you, Nicolas. Please do not hesitate to continue to send questions or so that we can actually answer all of them as much as we can.
Yeah, there was a couple of questions in the very beginning that we still have not addressed. I think we can answer them now. Mark asked, how do you perform QoS, such as a 5G latency, throughput, packet loss with our solution currently? Maybe Anurag or Vijay, you can answer.
Well, maybe I can answer. We have introduced QoS, and we're going to introduce it in the next version of our software that's planned for the end of this quarter. Version 3.1 will have QoS. We're introducing 5 QIs, 5 different levels of 5 QIs to be able to manage 5 different types of priorities. Is that Anurag or Vijay? You can elaborate or confirm if you want.
Anurag, we can't hear you.
I'm sorry, Nicola, I think I missed you a little bit. Your voice broke for me too.
Okay, sorry about that. Just mentioned that QoS is planned in our next version, 3.1, and will be released at the end of this quarter.
Yes, so the plan is to release a basic QoS by the end of this quarter. So we will have support at the core network, at least on the control plane, and we are also trying to start the work on the data plane as well by the first quarter of 24.
Okay. Nitin also asked, how stable is OAI? Can we run for 24 hours with full throughput if the right processing setup was there?
Yeah, so today the code base that we have used for the initial release is based on week 25, and we are using the bronze release of ORAN. So currently, as we are speaking, we are migrating to release as well. So there are some impacts on terms of stability, like when we run for like 7-8 hours, it's impacting. But yeah, it's not like like stability is not impacted so much, because in some scenarios it doesn't create any problems. But yeah, it's an old code base, so there are some gaps.
Okay. Just gathering the questions. Daniel's question was answered as well. Okay.
I have one question. Is it okay if I ask now, or should I wait?
Yeah, sure. Please go ahead.
Thank you. So for the ORAN, right, so there are CU, DU, and RU components that you have. So since you have support for most of the ORAN interfaces, I'm assuming that they can be interchanged with other CU or DU from other vendors and can work. And similarly, it applies also for the 5G core network functions. Is that possible?
That's the theory. That's what OpenRun has been released for. And in theory, you can interchange CUs, DUs, RUs, and it should work without any effort. What we're seeing concretely is that it still requires a considerable amount of effort. And thanks to OAI and our team that are working on integrating more and more OpenRun radios, OpenRun CUs and DUs, this effort is significantly reducing in time. So I believe that within a year or two, this should be the reality. But that's not what we're currently facing with this new technology.
So one question, right? Have you tried to components from other vendors?
Sorry, Dipanjan, can you please repeat that? We didn't hear it.
I think the question was, have we tested with components from other vendors? So we at Firecell, we're building our own complete solution, and OAI has a different role, and the OAI's role is also to contribute in the form of interoperating with other components.
Yeah, so this is Raphael speaking from OAI. So at OAI premises, we are testing with Benetel VVDN, such as the one that are using by Firecell and Lighton. We are also partnering with other partners that are not yet officially supported, but they are testing also our source base, like something like analog device or even ATUS, so that. So as Nicola mentioned, I mean, it's not easy. It's not plug and play yet for everyone.
But we're working on it, right?
Yeah, everybody's trying to working on it.
Okay, there's a few other questions that we can answer. Oh, just a second. Someone asked, how can we collect the real-time radio data, such as power, latency, etc., for indoor 5G environment using LabKit 40?
So some of these parameters are already being collected by the CLI, like the power-related information, for example. But we do not have all of the data being collected from the RU at the moment. But this kind of integration is ongoing to get as much information as much as possible from the RU at the moment. But yeah, so this is being mentioned inside the demo. Like we are collecting some of the information from the RU, which is really useful for the user.
Okay, I think we can take a couple more questions. Next, Benjamin asked, do you see a requirement for interconnection of private mobile network with MNOs? If so, how do you address it? Maybe.
There are several ways of addressing it. One of the ways is by having specific SIM cards, and we have partners that are able to provide dual SIM cards that can switch from the private network to a public network automatically according to your location or according to something that is triggered by an API.
Hello, can you please hear me?
Mm-hmm.
Yeah.
Thank you. My name is Mohammad Wasim Akhtar, and I'm working as a lab engineer at Mid Sweden University. And we are using currently Firecell's LabKit 40. I have like a couple of questions regarding that. Like, can we use this Firecell LabKit 40 for ORAN use cases?
No, you will have to upgrade to an ORAN lab kit because it uses different hardware. For ORAN, there's a different network interface, and the radio obviously is an Open RAN radio.
So we need to buy ORAN lab kit. Like this will not work for that.
Yes, but we have a specific upgrade plan for customers who already have LabKit 40. So you can contact us and we'll provide you with a specific quote for you.
Okay. There are like 2 or 3 more questions. Like if we are using user equipment, mobile, and we connect it to the lab kit, and we use it as a hotspot to connect the other UE or laptops. So the issue is that there is a IP conflict when we are using UE mobile station as a hotspot. So how we can manage the IP addressing so that we can communicate between different laptops connected with the lab kits?
Okay, I don't think we can address this technical question during this this call, but Anurag will be happy to answer offline. However, we are aware that there are improvements to be made in the easiness of integrating our different lab kits into an existing network, and we are working on a task called 5G LAN, which will improve the easiness of integrating the a private 5G network into existing networks. So DHCP, IP address sharing will be automatically answered, will be automatically covered, and you won't have to do particular settings, which you need to do with the current versions.
Okay, thank you. There's one more question. If we are using this lab kit for the 5G private network deployment, so like for the indoor environment, we use some robot or some other robocars. So is internet necessary for the communication between different nodes, or we can use it without internet as also?
No, it's not necessary. It's not necessary to have internet.
Okay, thank you.
All right. All right, great. I think we can take one last question. We have a question about frequency bands for Nikolai. I think you can answer this one. So the question is, do you still need to take authorization to use frequency bands, or do you only use low power, ensuring no interference with BS of other operators?
So in theory, you are always supposed to ask for permission to use those frequencies. In practice, don't quote me, I didn't say anything, but if you're using it indoor in a lab and no one even knows from the outside that you're emitting, there will never be any problem. But in theory, the most regulators will ask you to declare that you're using a specific frequency. And especially, of course, for outdoors, there's no question about it. For indoor, if you use it reasonably inside a lab that won't interfere with the public network, most of our customers don't ask for a specific frequency for using a lab kit indoor. Okay.
Yes.
I have one question, and a short question, very short question. So for the ORAN use case, if we apply the RAN intelligent controller, so it would be a separate hardware, or it would be like a software, complete software that would be installed inside the lab kit?
So you're talking about RIC, the RAN intelligent controller.
Yeah.
This is a work that we're doing with OAI, and my understanding is it's completely software.
Okay, thank you.
Maybe guys from OAI can confirm that. Okay. And regarding eSIM, yes, we're working with different vendors to integrate eSIM in our next products. And handover, LabKit is sold with one radio, so it's not easy to do handover with one radio, but handover is available with multiple radios in our commercial products. And the question, a nice question was asked about, do we get back our development into OAI? And the answer is yes, we are contributors of OAI. And it's really, as Claude explained in the beginning, a win-win situation where everyone contributes to the code so that it gets better. We get the updates from OAI, and we also provide our updates to OAI. And at the frequency, Anurag, last question maybe by Usha.
Yeah, maybe I can take this question. So we are working on the end-to-handover feature now, so it's only to be contributed back to OAI. We have some fixes which we committed recently. So the first feature from Firecell will be like the end-to-handover will be pushed back in coming weeks.
Okay, and there was a question about geolocation. That's also something we're working with jointly with OAI, and that will be available by the end of this year. Demos in Q2, hopefully, in some fairs, trade fairs.
Okay, thank you, Nicola. I think that we answered most of the question. I'm going to put in the chat the contact email address if you have more questions to ask to the Firecell team. So you can find it now in the chat. With that said, I'm thanking everyone for your support and for be there in this webinar. Thank you at the Firecell team for this excellent webinar, and I wish you all a great day, and I hope to see you in the next webinar. Thank you, everyone.
Thank you. Bye-bye.
Bye-bye.